Hello, I am Pradeep Kaur, lecturer in chemistry. Today I am about to deliver a new topic for 11th class in the unit chemical bonding and molecular structure, and today's topic is covalent bond. Now first let us understand what this bond is and how it is formed, which elements are capable of forming this bond. In the last topic, we had discussed electrovalent bond, that is ionic bond. In that very topic, we had taken those elements which could lose electrons to become stable, and they were forming bonds with those which could gain those lost electrons by one of the elements, forming ions. But here no ion formation, no oppositely charged ions are formed. Here mostly such elements are taken which are deficient in electrons. The combining atoms, the atoms which combine by means of this bond, they are electron deficient. That is, they require more electrons to become stable. And thus what happens in this bond? The combining atoms, they contribute and share the electrons, forming a special class of bond known as covalent bond. Sometimes there is sharing or mutual sharing of one pair of electron, sometimes it is two pair of electrons, and at some occasions there can be sharing of 3 electron pairs. So it depends upon whether there is sharing of 1 pair, 2 pair or 3 pair of electrons, forming single, double and triple covalent bonds. The double and triple covalent bonds are also known as multiple bonds. So first let us go to the definition of this bond. What this bond is. This bond is formed by mutual contribution. Contribution means that electrons are contributed by the combining atoms. The atoms which have to combine through this bond, they contribute electrons. Some electrons are contributed by one atom and some are contributed by another atom. That is called mutual contribution. This bond is formed by mutual contribution and mutual sharing. First there is contribution followed by mutual sharing. That is, those electrons are shared. Mutual contribution and mutual sharing of electrons. Electron or electrons between combining atoms. So this bond is formed between those atoms of elements which are electron deficient, which require electron so that they become stable and acquire the electronic configuration of nearest noble gas. Now let us take some examples. For example, formation of H2. Now H2 molecule can be formed by 2 hydrogen atoms. This is one hydrogen atom, this is another hydrogen atom. Let us go to their electronic configuration. Hydrogen has atomic number 1 and so has this hydrogen atom. So how many electrons it has? It has 2. It has 1 electron and it too has 1 electron. Now this atom of hydrogen requires 1 electron to become stable. so that it gets 2 and acquires the electronic configuration of nearest noble gas, that is helium. As you know, helium is also a stable element because it acquires duplet and so it becomes stable. So this hydrogen atom can become stable if it gets one more electron. And same is the case with this hydrogen atom. It also requires one electron to become stable. So in this case, neither this electron will go to this and nor this electron can go to this. So what happens here? Here this hydrogen atom and this hydrogen atom, they contribute their one electron. It will contribute one and so will do this, like this. Hydrogen, this electron will be contributed by this hydrogen atom and this will be contributed by this. They will contribute one electron forming a bond. This will be a single bond. So single bond is formed when there is one pair of electrons. This is one pair of electron. So this is H single bond H. This single bond is covalent bond or single covalent bond, and as a result hydrogen is formed. So this is one. So this bond, which is formed by mutual sharing of one pair, first contribution, first they were contributed and they were shared and later they were shared, forming this bond, and as a result your hydrogen molecule is formed. Now I can take one more example. Formation of O2 molecule. O2 molecule can be formed by two oxygen atoms, 1 and 2. Now see, what is the electronic configuration of this oxygen? Atomic number 8 and electronic configuration of 2, 6. So how many valence electrons are there? 6. 1, 2, 3, 4, 5, 6. And so is the case with this oxygen atom. 2, 3, 4, 5, 6. Now just see. This oxygen atom requires 2 more electrons to become stable, so that it gets 8 in the valence shell and acquires the electronic configuration of neon, which has the atomic number 10. Same is the case here. So how they will become stable? Now it will contribute its 2 electron and it will also contribute its 2 electron, like this. O and O. These 2 electrons will be contributed by this oxygen atom and these 2 will be contributed by this. So there is contribution and now they will share. Now it will have 2, 2, 2, 2, 2, 2. Now these 4 electrons, they are mutually shared. They are shared mutually between these 2 oxygen atoms. Now see. Now this has become stable. These 4, they are mutually shared. They are with this oxygen atom as well as with this. So as a result, this forms a double covalent bond. Double covalent bond. Now one thing is to be kept here in mind. These electrons, these which forms bonds, these are called bond pairs or shared pairs. These are bond pair. These electrons are known as bond pairs. So what are bond pairs? Bond pairs are the electrons which form bonds. They are also known as shared pairs. While as other these electron pairs which are not taking part in bonding, for example this pair, this pair, this pair, this pair, they are known as lone pair. What are lone pair? Lone pair are those electrons which do not take part in bonding. So as a result, O2 molecule is formed. And this is double covalent bond. So what is a double covalent bond? Double covalent bond is formed between atoms when there is mutual sharing of two pair of electrons, two pairs. This is another example. Then coming to one more example, formation of N2 molecule, that is nitrogen. Now see here, two nitrogen atoms, atomic number 725, its electronic configuration, and same is the case here. How many valence electrons? 5. 1, 2, 3, 4 and 5. Same will be the case with this nitrogen atom. Now see, how many electrons are required by this? 3. How many by this? 3 to become stable. So they will first contribute these 3 and then they will mutually share like this. These will be 3 pairs. Now these 3 pairs, they are mutually shared. They are with this nitrogen atom as well as this nitrogen atom, forming a triple covalent bond between two nitrogen atoms. Triple covalent bond. And as a result, N2 is formed. Now here, in this bond, you are finding that there are 3 pairs, 3 electron pairs which are forming bond. These are bond pairs. These are bond pairs, are shared pairs of electron. While this pair which is not taking part in bonding, it is lone pair. Similarly, this is also a lone pair. So this is another example of covalent bond, triple covalent bond. So a covalent bond can be single, double as well as triple, depending upon the number of pairs that are contributed and then shared. Now let me take some other example. For example, I take the formation of ammonia. The formation of H2, O2 and H2, O2 and N2. These were homoatomic molecules. Homo means they had same atoms, 2 H atoms, same atoms, 2 oxygen atoms, same atoms, 2 nitrogen atoms, same atoms. So these were homoatomic molecules. Now let me take some heteroatomic. Heteroatomic molecules means those molecules which have different atoms. For example, here we have nitrogen and then hydrogen atom. Let us see how bond formation takes place in ammonia. How many nitrogen atoms are here? 3. 1 nitrogen atom, not 3. And how many hydrogen? 3. 1, 2, 3. Let us see how bond formation takes place here. What is the electronic configuration of hydrogen? 1. That is, they will have 1 electron each. What about your nitrogen? Nitrogen has atomic number 7, having electronic configuration 2, 5. How many valence electron? 5. I will show those 5 electrons. 1, 2, 3, and then remaining 2. That is 5. Now we have to make all these atoms stable. Now see how this hydrogen atom will get stable. It requires 1 electron, 1 more electron to become stable. So there will be mutual sharing of this pair, this electron of nitrogen and this electron of hydrogen, like this. Similarly, there will be mutual sharing of this pair between nitrogen and hydrogen. Similarly here, now how many bonds? Single covalent bond, single covalent bond, single covalent bond, and then this pair which is not taking part in bonding, this will be lone pair. So this gives rise to the formation of ammonia molecule. So in ammonia molecule there are 3 single covalent bonds, and as a result we have a 1 lone pair here. And one more example, for the formation of say methane. having molecular formula CH4. Now I have a carbon atom here and 4 hydrogen atoms. 1, 2, 3, 4. Let us go to the hydrogen atom first. 1 electron, 1 electron, 1 electron and 1 electron because it has atomic number 1. Then your carbon has atomic number 6. Electronic configuration 2, 4. How many valence? 2, 4. If 2, 4 is its electronic configuration, how many valence electrons? 4. 1, 2, 3, 4. Now, in order to make these hydrogen atoms stable, these 4, 1, 2, 3, 4, there will be mutual sharing of 1 electron in all cases, like this. H, mutual sharing of 1 electron between H and C. Here again H and C. Here again H and C. Here again H and C. So as a result, 1, 2, 3 and 4 single covalent bonds are formed, and these are all bonded pairs, that is shared pair. They are forming bonds, no lone pair at all. So as a result, methane is formed. But this is not homoatomic molecule. These are heteroatomic, having different atoms. This was also heteroatomic molecule. So what is now a covalent bond? A covalent bond is a bond which is formed by the mutual contribution and mutual sharing of electron or electrons. They can be one pair of electron, that can be 2 pair of electron, and sometimes it can be 3 pair of electrons, and as a result we have single, double and triple covalent bonds. Now the compounds that are formed as a result of this bond. For example, I just had covalent bonding in ammonia. I had covalent bonding in this methane. I had covalent bonding in hydrogen, nitrogen, oxygen. So these compounds where we have covalent bonding, they are formed by covalent bond. Such compounds are known as covalent compounds. So all these compounds are covalent compounds. Now let us come to some characteristics of covalent compounds. Characteristics of covalent compounds. First characteristic is physical state, that is in which physical state they occur. These compounds, they exist as solids, liquids and gases as well. So you can find these compounds, that is your covalent bonds, in solid state or liquid state or in gaseous state. Then another property is their melting and boiling points. This point, that is melting and boiling points, it depends upon the strength of the bond. Now your ionic bond that was formed between oppositely charged ions, that was a strong bond. So those compounds, that is your ionic compounds, had high BP and MP. As compared to ionic bond, your covalent bond is a weaker bond. So these compounds have low BP, that is low boiling point and melting points. Reason very simple, that the bond in these compounds is a weaker bond. So these compounds have low melting and boiling points. Then third is conductivity, electrical conductivity, whether current passes through them or not, that is electrical conductivity. Now since these compounds, these covalent compounds do not have ions, there are no ions in this compound, so they are poor conductors of electricity. They are poor conductors of electricity owing to the fact that there is absence of ions. There are no ions in covalent compounds. Then coming to your solubility, that is which solvents dissolve these compounds and which not. These are soluble in organic solvents but not soluble in water, that is insoluble in water. This property is quite opposite of ionic compounds. As if you remember, ionic compounds were soluble in water. These are insoluble in water. They were insoluble in organic compounds, but these are soluble in organic compounds like benzene, alcohol, etc. This is solubility. Then coming to nature of reactions, that is what kind of reactions they undergo. These compounds, that is your covalent compounds, they undergo molecular reactions. Molecular reactions. And these reactions are very slow. They have very slow rates of reaction. And finally, one more characteristic of covalent compounds, that they undergo isomerism. As isomerism, as you know, this is a phenomenon by which a compound can exist in different structural formula but similar molecular formula. So such a phenomenon is known as isomerism. And as far as your covalent compounds are concerned, they show structural as well as space isomerism. Two types of isomerism is shown by these compounds. So this is all about covalent bonding. Thank you very much.